How do registers enable peripheral interfacing in microcontrollers? Imagine trying to talk to a device without a proper language or signals. That's what microcontrollers face when connecting to external peripherals. Registers are the key to this communication. They act like control panels or switches that tell the peripheral what to do and read what it is doing. These registers are small storage areas inside the microcontroller, usually a fixed size like 8, 16, or 32 bits. They hold important information such as configuration settings, status updates, and data values. When the microcontroller wants to communicate with a sensor or display, it writes specific values into these registers. This action sets up the peripheral's mode, like turning it on or choosing how it should operate. For example, a control register might tell a display to turn on or set its brightness. Status registers are like a report card that shows if the peripheral is ready, busy, or if an error has occurred. Data registers are used to send or receive actual information. If a microcontroller reads from a data register, it gets the latest sensor measurement. If it writes to a data register, it sends commands or data to the device. For peripherals like general-purpose input-output pins, direction registers decide whether a pin acts as an input or output. Setting a bit in this register makes the pin listen for signals or send signals out. When the microcontroller starts up, it writes values into these registers to set everything up. During operation, it can change bits to control peripherals dynamically. For communication protocols like serial peripheral interface, registers manage protocol details like clock polarity, phase, and data size. They also control chip select lines to activate specific devices on the bus. The internal shift registers in peripherals handle serial data, but the main control happens through these registers. By changing bits in control registers, the microcontroller can start or stop data transfer, change modes, or reset devices. Reading status and data registers allows the microcontroller to monitor sensors and communication status in real time. Writing to data registers sends signals or data to external devices. This process makes peripheral interfacing smooth and flexible. Registers are the essential link that allows the microcontroller to configure, control, and communicate with all kinds of external hardware. They make it possible for embedded systems to work seamlessly with sensors, displays, motors, and communication modules.